Now we're recording it. So the last lesson that we had, we were talking about square roots, right? And it was kind of a review. You guys did that stuff in Algebra 1 before, but you probably hadn't looked at it in a while. And we need to do square roots because we're going to be approaching the quadratic formula, and that deals with working with things under a square root. And then we were using square roots to solve. But there's some instances where we can't use a square root to solve because there's no real solution. And so what we're going to be talking about is, we're going to be talking about me turning the pen on. Let's do it in gold. We're going to be talking about the imaginary numbers. You're like, I know, real numbers are hard enough. Now you're giving me imaginary numbers. And they're part of the complex number system, which is way easier than its title makes it sound. But the imaginary numbers came from when mathematicians back in the day tried to solve questions like x squared plus 1 equals 0. And if we were looking at what we did earlier this week, we would know that we should be able to just solve this for x squared, right? Get x squared all by itself by moving the 1 over, and we would have x squared equals -1. And when we were doing this the other day, we were going to take the square root of both sides, and that would be our solution. We would get x equals whatever the square root of this is, right? Plus or minus. The problem is what number times itself equals -1, or negative anything for that matter. Because if we were to multiply 1 times 1, we would get 1. And if we were to multiply -1 times -1, we would still get +1. So when we try and take the square root of a negative number, it doesn't work because nothing times itself gives us a negative. And so mathematicians came up with this thing that we call the imaginary unit, right? And the imaginary unit we just call I, right? And what we say is that I equals the square root of -1. So if I were to do this right here, I would say that this is plus or minus I, right? Because remember, we had to have a plus or minus because -1 times -1 equals 1, and 1 times 1 equals 1. And when we break this down, we look at it as, say I had x squared equals the square root of -1. When we break this down, what we're looking at it as is the x squared equals the square root of -1 times a, right? Whatever that a is kind of how we're looking at it. So we could pull this out, and then all we're left with is that other number. So say it was x squared equals -4, we would look at it as -1 times 4, and we could pull this out. When I'm doing it, I don't even think in those terms. The minute I get to a problem where it says x squared times, say, -1, what we started with, I automatically just pull out the I. To me, I read this as I times the square root of 1. Right? And then I can figure out what the square root of 1 is. And in this case, it's just 1. So it'd be plus or minus I. When I look at this one, if I had x squared equals the square root of -4, I see this as plus or minus I times the square root of 4. Right? And then I would just take, well, the square root of 4 is 2, and I would write that as plus or minus 2i. Does that make some sense to you? Okay. So the first important piece of information that you learned today is that I equals the square root of -1, right? The next important piece of information you will learn today is that I squared equals -1, right? These are the two biggest bits of information I can give you today, right? And if you think about it, it makes sense, because if I have the square root of 2 times the square root of 2, it just gives me 2, right? Or if I had the square root of 2 squared, which is the same as this, right, I would just get 2, right? Anytime we square something under a square root, it just gives us whatever it was under the square root. So in this case, if we're squaring -1, right, we're saying I is the square root of -1. And if we square it, it should just give us -1, right? Which is how we can say that I squared equals -1. So that's just an explanation for it all. But your best bet would be to just memorize this bit right here. So let's look at a few sample problems with this information that we've been given, right? What we were doing last week was simplifying square roots, right? We were taking, or earlier this week, I should say, we were taking things like the square root of -9, right? Or the square root of 9 is what we were doing then. But when I look at this, I can go, well, I know the square root of 9 is 3, and this negative just makes it 3i. So it would be plus or minus 3i. And they won't always be that easy, because remember earlier this week when we had them, we had to break things down. So if I had the square root of -80, I would have to look at this as plus or minus I times the square root of 80, and then figure out this 80. Look at it, I'll go, okay, well, it's 4 times 20, right? And 20 is 4 times 5, so I can pull these 4s out, but the 5 is going to have to stay, right? Because it doesn't have a pair and I can't break it down anymore. So the square root of -80 would be plus or minus 4i, and I still have to have this 5 under the square root. So we're just adding an extra step to exactly what we were doing earlier this week. Any questions regarding that? Do you want to see some more of those that break it down? All right, I'll keep going then. The next thing that we did last week is we were taking, once we figured out how to break down these square roots, and they say simplify them, but really they're making them more complicated because they were pretty simple right under the square root. But once we figured that out, the next thing that they had us do was they had us solving equations using the square roots, right? And we learned that if we had anything of the form ax squared plus or minus c, right? No bx value, right? We didn't have that. We had a square and we had a number that we could solve them using square roots. And what we did was we took a problem like x squared plus 81 equals 0. And the first thing that we did was we isolated x squared, right? We got it all by itself. Isolate x squared. That means the only thing we want on this side of the equal sign is x squared. So we do that by undoing anything else that might be being done to it. In this case, the only thing happening to x squared is we've got 81 being added to it. So to undo it, we have to subtract 81 from both sides. And so we're left with x squared equals -81. And then the next step was to take the square root I can't spell. Square root of both sides. Right? Which means that we just come in and we literally take the square root of both sides. And here we're going to have x equals. Now I have that negative, so I already know I have this plus or minus I times the square root of 81. What is the square root of 81? What number times itself gives us 81? This is a perfect square, so. That is a question I'm putting to you guys. What number times itself gives me 81? 1 times 1 equals 81? We're saying what number times itself. When we're talking about squares, we're saying things like, well, 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. So we're saying what number times itself, right, squared, will give us 81. I understand what you were saying. I just did the question right. 9 times 9 equals 81. So we could go plus or minus 9i. Does that make a little more sense? Does that help? We'll look at another one. There's always more to see. So example, here we have 2x squared plus 9 equals 1. So we have to isolate, right? We want x squared to be by itself. So we have to undo everything that's being done to it right now. So right now we're going to start by subtracting 9 from both sides. And we have 2x squared equals negative 8. But I can't stop there because we still don't have just x squared. We also have this 2 being multiplied to it. So we have to do the opposite of multiplication to move it, which is division. So we're going to divide both sides by 2. And we will get x squared equals negative 4. Then we've got our x squared isolated. It's the only thing on this side of the equal sign. So our next step is going to be square roots of both sides, right? Let's go purple now. I'm using a lot of colors on this. So I take the square root of this side and the square root of this side. What do we know automatically with that negative? What do we automatically know when we have a negative under the square root? What do we do? Well, no, it's going to be plus or minus. What was I saying the square root of negative 1 was? What did I say we do the minute we see a negative underneath there? It turns into I. To pull out an I. So I can make this plus or minus I. And now we have times the square root of 4. Right? And now all we have to look at is, well, what's the square root of 4? So what number times itself equals 4? 1 times 1, 2 times 2, 3 times 3, 4 times 4. What number times itself equals 4? 1 times 1 equals 1. Yeah, but I need to know what number times itself. So is it 1 times 1 or 2 times 2? Or there we go. So you got that 2, and then we got to put the I back. And that's our answer. Right? So all we have to do when we see that negative is whatever happens, it's that plus an I. So when we take the square root, there's going to be an I, right, if we have a negative. And I'm going to do one more because I feel like we're moving a little slow on this one. And I want to make sure that you guys are totally getting it. And then I'll let you guys do the rest. Well, with the Edpuzzle almost. Then I'll present you with your extra credit thing, and then I'll leave you be to go do your Edpuzzle. So this is my third and final example. Here I have 4x squared plus 15 equals -9. First thing we're going to do, isolate, right? We're going to get that x squared all by itself. We're going to do that by undoing everything being done. So we're going to start by subtracting 15 from both sides. And we will get 4x squared equals -24. The next thing we do, we still have 4 multiplied to it. And if it's multiplied, I have to do the opposite of multiplication to move it. So I'm going to divide by 4 and divide by 4. Because you can't do it to one side and not do it to the other. And I will be left with x squared equals -20. No, that's not what I'll be left with. I don't know what I was subtracting or something. What is 24 divided by 4? It's 6. We'll be left with -6. See, we all mess up, right? Now, the last thing that I have to do is take the square root of both sides. And when I do that, here I am left with x. And here I am just going to be left with plus or minus I times the square root of 6. I can't break down 6 any further. It's 2 times 3, and those aren't the same, right? 2 and 3 aren't the same. Just like 1 and 6 is also factors, but those aren't the same number. So I can't pull anything out. I can only pull something out if I have a pair. So this is as far as this problem will go for us. Right? Does that make some sense? That we can't break this down, right? Because there's no perfect square. All right. So the last thing that I need to go over with you guys, because the Edpuzzle will do the multiplying them out for you. But what I want to show you is that there's patterns in this. And when we're talking about powers of I, powers of our imaginary, powers of I, we know that if we have I to the first power, that's just I, right? And we were told that if we have I squared, that is -1. I told you that, and I showed you how up above. I to the third, well, that's just like saying I squared times another I, right? And if we know that this is -1, and we multiply it times another I, we just get -I. So this is just -I. If we have I to the fourth power, well, that's like saying I times I times I times I, right? And we know that 2 of them is -1, and these 2 are -1. And if I multiply -1 times -1, I get +1, right? I to the fifth, well, that's like saying I'm going to take this right here and multiply it times another I, and 1 times I just equals I. I to the sixth, well, that's like taking this and multiplying it times another I, right? And that would just give me -1. And what you'll see, so sorry, this is I to the sixth, it looked like I squared. I to the seventh would be -I. I to the eighth would be 1. And we can follow this pattern forever. I to the ninth would go back to I. I to the 10th, well, that would be -1, and so on, right? So notice that no matter what I raise the power to, there's only 4 solutions, right? It's either going to be I, -1, negative I, or 1. And your extra credit, and it's written up in PowerSchool, so I'm not going to rewrite it here, is to come up with a formula or an algorithm to explain how to use it to find I to the 127th power and I to the 412th power. Because we can use this pattern to figure out I to any power. And so it's worth 100 points extra credit up to. So even if you get it and you don't, if you give it a try and you don't fully get there, that's okay. You can still get partial credit on it. It costs you nothing if you don't try. It's just an opportunity to make some extra points and to think about things a little bit. Any questions regarding that? Daniel's good. Anybody else have a question? Okay, well, that is all I have for you today. Make sure you do your Edpuzzle and the worksheets from this week, right? You had one for square roots earlier this week, and you have the one for the imaginary numbers today. They're due Sunday, so just take pictures of them and email them in once you finish. And other than that, I got nothing for you. You know, I guess you could have a great weekend. Daniel's got a great weekend coming up because he's getting a puppy. Yeah, you got to show and tell a puppy, man. I have a kid in my other class. She hasn't shown me the new puppy yet, and she tells me like stories about this puppy every time she comes in. She's not put them on camera yet. Is this Abby? Okay.